What's up, everyone? My name is Dr. Chris Hacks, and welcome back to another CryptoPals Crypto Challenge, Challenge 12, Byte-at-a-time ECB decryption. Alright, so this is kind of what we've been building up to. We're actually going to finally decrypt ECB mode. It is a little bit tricky, but it is definitely doable, which isn't a good thing for anyone using ECB mode in the real world. So let's actually jump into how we're going to do it. So we're going to copy our Oracle function to a new function that encrypts buffers under ECB mode using a consistent but unknown key. All right, sign the key once, blah, blah, blah. Okay, we're going to take this string, and this string is currently encrypted. I believe it's in base 64. Yet we don't actually know what it means. And it says, don't decode it now. Let's not decode it now. Yeah, it is base 64. So we are not going to decode the string, and we don't want to know what it is, because this is going to be like our flag, more or less. We're going to be trying to figure out what it actually is. So now we have a function that does this. We pass in a string that we create, and then we have an unknown string. Okay? And then we have a random key that's going to be consistent throughout this entire process. And that is important because we have to be encrypting under the same key, otherwise we're not going to be able to figure anything out. And it turns out we can decrypt the unknown string with repeated calls to the Oracle function. So here's how to do it. So we're going to feed in identical bytes of our string one at a time. So we'll start with like A, and this is to discover the block size. So we already know the block size is 16, but just in case we don't know that, this step is to do this. Next, we're going to be detecting that it's using ECB mode. We already know that it's going to be doing this, but we're going to detect it anyways using repeated blocks function and just to as a proof of concept. Okay, now that we know the block size, we can create an input that is exactly 1 byte short. And then we're going to figure out what the Oracle is going to put in the last position. So I'll show you guys how to do that. Make a dictionary of every possible last byte by feeding in different strings, match the output, and then repeat for the next byte. Okay? So because of the repetitive nature of ECB, we're going to be able to do this. So yeah, we'll be able to basically build up a key and then just straight up decrypt it ourselves. So there we go. So let's jump right into our code, and I will show y'all how to do this. We are going to need a lot of stuff. We are going to need challenges, AES, encoding utils, and random.h. And then let me actually implement challenge 11, or challenge 12. Okie dokie. So next up for what we're going to do is, here's roughly the steps. So first we have to find our block size. So int block size equals, I'll make a function called find block size in a minute. So we have to figure out how big our block size actually is. Okay, then we need to detect what encryption algorithm we're using. So if has repeated blocks, and then we'll pass in our block size and our encrypt, then we can do that. And then once we know if it has repeating blocks, it's actually CBC mode, or I'm sorry, not CBC mode, ECB mode, then we can move on to actually decrypting this. So let's just take this step by step, one at a time. Let's start with, well, first I need to implement a couple of helper functions. Since we're not actually allowed to call the encryption function ourselves, here's what I'm going to do. So let's do this. First we need a key, so let's do key. Yeah, const string key equals generate random bytes, and we'll have a 16-bit key. So that will give us a key that we can use throughout. We, as the end user, won't use this. This will be like server-side code, practically. And then what we'll do is we will have a string. I'm going to call this, we'll call this black box encryption. Black box encryption. done. And then all we're going to pass in is our input. And those are the functions we can call. This will be like server-side code. Us as the user, everything below this will be like user client-side code. We're not going to be able to like see these functions. We're just able to call them. That's it. So we'll have our const flag, our string flag, and that is right here. Let me make this all one line. Okay. Hold up. What the heck happened here? I need to get rid of that. Let me just make sure. Yeah, just make sure to copy your string over. Yeah, okay, there's just spaces there. Okay, yeah, just copy your string over correctly because that's important. But yeah, there's our flag. Okay, once we have our flag, we can do our encoding. So we'll do this. Plain text is just going to be equal to our input plus our flag, but we have to base 64 to code our flag. That way we can actually get the correct thing. We want to make sure that we get the right like text, because this is actually like plain text. It means something, so we want to get that, not just this random garbled junk. Okay, so we can actually make this constant. And then we will just return AES 128 ECB encrypt. We'll pass in our plain text and our key. Cool. Okay, and that's our black box encryption function. So for the rest of the video, we can't see it. We don't know what's going on in there. And we have to figure everything else out ourselves. All right, so the first step here is we have to actually find the block size. So I'll make a function to do that. Int find block size. So let's assume we don't know what the key is. We don't know what the key size is. So we're just going to do this. String plain text. And it's just going to be an empty string, so I'm just going to pass in 0, 0. Literally will be an empty string. Or I guess I could just initialize it like this. That also works. Now, here's what we have to do. What we're going to do is we're going to start with an empty string and encrypt it and get the length of it. Then we're going to have a second length, and we're going to gradually increase the size of that second string until we get the a new encryption, basically, or a new encryption length. So let's say, for example, we have a size of 0. We pass in a 0 size string. That 0 size string, well, we already know that our plain text is going to be included up here, but let's say, for example, it just encrypted the string by itself. What it would do is it would basically have the same block size for the same input, and it will have the same length overall as you increase the input size until you hit the next block, basically. So let's say the block size is 16, and I pass in 16 A's, 1, 2, 3, 4, like whatever, right? So imagine that's 16 A's. Then I pass in another A. All of a sudden, the length is going to jump up by 1 block size. So we can compare the two lengths and subtract length 2 from length 1, and that will leave us with whatever the jump is, and that will be our block size. So let's just implement that. So int length 1 will just be, call this black box encryption, and we will pass in our plain text, and we want the length of it. And then we'll have int length 2, and we'll just set that equal to length 1 for now. Now we can just make a simple while loop. So while length 1 is equal to length 2, we are going to do plain text plus equals, we'll just put an A, because why not? Doesn't really matter what we put. You can put any character here, doesn't matter. Just use A, keep it simple. Then length 2 will just be black box. Encryption, we'll pass in plain text dot length. Then as we slowly increase, eventually the lengths will be unequal, and it will be unequal by exactly 1 block size. So we can just return length 2 minus length 1. Perfect. Now we know what the block size is. It's going to be 16, of course, but now we actually know that. All right, so next step. We have to actually detect our encryption algorithm. So the way to do that is, actually, I'll build a function for that. Instead of using repeating blocks, we're going to use repeating blocks, but yeah. Basically, I'll call this, okay, let's call it this. Bool detect, and then I'll call it detect ECB. Or I'll call it is ECB. Is ECB. And it'll either turn true or false. And all we have to do is pass in the block size. Okay, so we don't know what the block size is. It could be anything. So we're going to make a string. And I'm going to do, let's call this plain text. I'm going to do 4 times the block size. So I'll just do block size, and then we'll just shift it to the right twice. That's 4 times the block size. And then we can put in A as our character. That'll give us our plain text, and then we just return has repeating blocks, black box encryption, and then we just pass in our plain text and our block size. Perfect. So now we basically pass in 4 blocks worth of A, and if it repeats, which it should because it's ECB mode, then we can return true. If it doesn't, then that means we're using CBC or something else, and it will return false. So if has repeating blocks, then we can continue on. However, if it doesn't have repeating blocks, that is a little bit of an issue, so we're going to have to return an error. So let's just throw an error here. Can I throw error? Let me go back to like challenge. I'm gonna be lazy and grab it because I don't remember what I did to throw errors. Oh, it's AES. AES has errors. Here we go. Let's grab one of these bad boys. Okay. Plop this in here. For a runtime error, we'll say ECB mode not detected. Perfect. Okay. But once we do know that it is ECB mode, we can go ahead and let me return nothing here because I'm going to return from this if statement. Or actually, I'll figure that out in a minute. It's not over optimized yet. Here we can actually start doing the unknown string detection. So no, we don't want is repeating blocks. We want this. Is ECB, and then we pass in our block size. There we go. That's what we want. What does it matter about here? Oh, I guess you're right. It might have an if red. Could be an overflow. I mean, I know it won't, but we'll just do that just to make it happy. Because the compiler will optimize all this stuff for us. Well, it won't optimize this, but it should be fine. It's not a big deal. It's one operation. Anyways, let's do this. Let's do this. String. And I'll call this unknown, or I'll call this target. And then I'll return target down here. I'll do the same here. And basically what we're going to do is we're going to do target equals, let's call the function discover. Yeah, discover target. Because now that we know that it is ECB and it does have a block size of 16, which I'll pass in here. Now we know we can actually do our little trick to figure out what it actually is. So yeah, we'll just do that. So I'll call this, have a string here, and we'll call it discover. Yeah, discover target. And I'll take a block size as an integer. And what this will do is it will do what the program said, or what CryptoPals said to do earlier. We're going to slowly feed in different strings until we can get it. So what I'll do here is string, call it target, and then int, say target length is equal to, we can get the target length this way. Length. That will give us the actual encryption output of the target because we're passing in nothing. So we'll get the target by itself, which is what we would like. Okay. So yeah, now we can actually start doing our little trick. Basically what we're going to do is, for the entire length of the target, we're going to craft inputs and get a targeted block. So yeah, give me 1 second. Right, sorry about that. So yeah, so what we're basically going to be doing is we're going to get the unknown length. We're going to determine the length, the string we're looking for, the target string. And then we're going to continuously craft inputs that are the block size -1. And I'll show you the math in a minute, but we're going to basically craft these specific block sizes to isolate where the chunks are. Okay? And then we're going to match it and basically brute force every possible value to try to decrypt it and see if we can get something similar. So let me just write out the code, and it will make a little bit more sense once I wrote it out a little bit. So for int I equals 0. All right, so for int I equals 0, and then we're just going to iterate over the length. So target length and increment, of course. Oh, let me spell this correctly. Okay, so what we're going to be doing is we're going to craft the block size to actually be looking for where the seams are in between blocks. So we're going to be looking like every 16 bits or so, or bytes, to get the individual blocks so we can start brute forcing them. So I'm going to call this crafted input, and it's going to be a bunch of A's, but the length we want it to be is block size -1 minus I modulus block size. So let's actually go over what this math is doing. So we have a 16 passed in, and then we subtract 1, so we'll get 15. And then we are going to basically take, well, for the first one, it's going to be -0. So it's going to be 15 A's, and that should craft it to the right length so that we can start decrypting. And then we'll grab a target block as well. So let's do this. String target block. Or that might be a little misleading because our strings. That should be okay. You just have to remember that which is which. All right, black box encryption. Pass in our crafted input. And then what we're going to do is we're going to pull out the exact block that we want. So we're going to substring it and get I divided by block size times block size, and then it is obviously block size bits. So what this is doing, whatever I we're at, whatever iteration we're at, we're going to divide by the block size so that we can get the block number, basically. Multiply it by block size bits so that we get the right index, and then we need 16 bytes to actually get the block we want. So this is what we'll be doing to get our blocks. And once we have the right block, we're going to make a dictionary of all of them to basically find what we're looking for. Let me just show you what this is. So I'm going to create an unordered map, like a dictionary, like the CryptoPals was talking about earlier. Just string and then character. Call this block dictionary. And then another for loop for int j equals 0. And then we're going to brute force through every possible character. Okay, so here's what we're going to be doing. We're basically going to create a test input which is going to be our crafted input plus our unknown string, or our target, and then we're going to static cast j to a character. Okay, and then we're going to get a test block. It's going to be exactly the same as this code up here. This, and we're going to add it to our block dictionary. We're going to give it the whatever j was at that time. So we're going to build up this block dictionary, and what we're looking for is target block. So this target block right here is basically what we start with, and that's just going to be our crafted input. And if we take that and we go through this whole process of inserting everything into our dictionary, we should be able to find one that matches. And the one that matches, that character is part of the key. Or part of the unknown string, actually, I should say. Because of the way the blocking is built. Hold on, what's this error here? No operand. What is it talking about? Unordered. Oh, because I have the wrong thing. It's not a multi-set, it's a map. That's why. I might need to include that. Yeah, I need to include that. Let me include that real quick. Include unordered map. Okay, so that will give us our dictionary right there. And then we can just go through and return the actual target string that we just built. Or return target. Yeah, okay, so there we go. So yeah, so what it's basically doing is it will go through and look for this target block. It will brute force everything in the dictionary, looking for every single character. Once it finds the correct character in this target, because we're basically building the target ourselves. That's right. That's what we're doing. So we're building the target ourselves. So for every single character in the target, we're going to basically brute force it. We're going to try to figure out, hey, which character is this? We're going to add it to our crafted input, and it'll create the right block so that we can get the target back that we want. And then after doing this over however long the target is, which will be the length of this string right here, so this will be 185 times. Once we do that, we're going to have a fully built target, which we can return. It will already be base 64 decoded for us because we do that up here. And then after doing all of that, we can just return it. So let's go ahead and run this, and we should see some plain English text that we can all read. Now, CryptoPals does a pretty good job explaining this, and it took me a bit of time to adapt this solution based on their explanation, but it is a pretty good explanation, and yeah, that's all there is to it. So, ooh, that's not right. Let me make sure that I did everything. Target equals discovered block. Let's see what's going on here. Oh, I see what I did wrong. I forgot to actually add the found character to target. We need to do that as well, otherwise we're just going to get a blank string. block dictionary dot find, and then we're going to look for the target block. Alright, so if we can find the target block, then we know that we found the correct character for our string. So block dictionary find target block, and if that's not equal to the end, then hold on, did I put, I put this in the wrong loop. That is why. Let's move that real quick. We have to stay in scope. Okay, dot end. Cool. Okay, and then we can just do target plus equals block dictionary of target block. Okay, and that should be it. That should give us our entire string. So let's run this and make sure everything works. Still nothing. What happened here? Alright, let's do a little bit of troubleshooting real quick. So why is it not outputting our block? We have our target here. Let's see. So we are getting our length. It is going through everything. Let me make sure. So target is being set here. Well, luckily we have some breakpoints, so let's go and do some debugging. Alright, first breakpoint hit, perfect. Alright, so we see the block size is getting found correctly, and then is ECB is saying true, good. Currently the target has nothing, so we'll pass that in. Alright, so this is going to be slow, so I'm going to put a breakpoint here and just skip ahead. Alright, find. So it did work. So we got the first character, which is this weird Y character. Could just be, well, let's jump ahead again and see what happens. I see, so we're not getting what we want, because that's incorrect. So, let's just make sure that, what could be going wrong? Alright, well I'm going to do some debugging, and then I will get back to y'all. Alright, I figured out what I did wrong. We're creating this test input, but we have to actually use it. Otherwise, what's the whole point of making it? So that's what was going on. We were using the wrong variable. So let me restart this, recompile everything. That should fix it all. Also, I can remove all our breakpoints. Yeah, let's get rid of all those. Continue. And I took all the breakpoints away so it didn't stay up. Perfect. So there we go. We got the song lyrics. Now, let's just make sure that this is actually equal to whatever the original target string was, just to keep things consistent. So I'm going to do this. I'm just going to do this for some testing. Cout, and we'll use, let's see, base 64 to text flag, and then we'll end L, we'll end line, and if I close that window over there, now what we'll see is we should see the two identical things. Oh, that, yeah, well, just stop that real quick. Didn't think that one through too hard, but that's what it should be. So I don't know if you guys saw very clearly, but it did have the actual song lyrics correct. So let me move this down here real quick. I'll move that there, and I'll take this out of here. Perfect. So now, go ahead and decode the flag and then make sure it matches what our function outputs. Okay, let's see. So rolling, yep, and it looks perfect. It's completely decoded. So there we go. Let me get rid of this for testing purposes. I'll push all of this to the GitHub, and thank you all for watching. I'll look forward to seeing y'all in the next video.